Meet LTX-2, Master Text-to-Video and Precision Camera Control, the first open-source model uniting cinematic visuals with integrated audio.
Atmospheric stabilizers are now active. Please remain within the shielded sectors for your safety.
Learn how to do it in ComfyUI now. ComfyUI has different LTX-2 workflow templates ready to use. Text-to-video, image-to-video, and controlnet. Also for normal and distilled versions of the models. Lightricks has also published its own custom node pack, which also includes different workflows. Templates are great, but the workflows can be a little bit complex and difficult to understand. In this tutorial, you will learn to build simpler text and image-to-video workflows. Understanding the process will help you later in unlocking the full potential of LTX-2. Before starting, make sure that all models are installed in the right folders. I will leave links and instructions in the description of the video. LTX-2 is implemented as a two-stage pipeline. The first stage generates a low-resolution video from a prompt, which is upscaled in the second stage using a distilled LoRa. This is the core fundamental process, which can later be adapted to image-to-video, controlnet videos, or for video editing. But today, we only focus on text-to-video and image-to-video. Start with the default basic workflow. In the Load Checkpoint Loader, select the LTX-219B safetensors file. The clip model needs to be loaded with a different node. Search for the LTX Audio Text Encoder Loader and add it to the workflow. Select the Gemma 3 as text encoder, and make sure the LTX-2 model is chosen as checkpoint name. Replace the checkpoint clip connection with the one from the audio text encoder. The empty latent image node is replaced by the empty LTXV latent video node. Search for it and add it to the graph. If you want to just create video without audio, you can just connect it to the latent image input of the KSampler, as you would do with other video models. Because we are going to scale by 2 in the second stage, we divide by 2 the target width and height parameters. In this case, we use 640 and 352 for a 720 pixels final video resolution. LTX-2 works best at 24 frames per second, and can generate more than 10 seconds. So we set the length of the latent as 10 multiplied by 24, plus 1. But if you want to generate also audio, you need to start with a separated audio latent with its own VAE. Add the LTXV Audio VAE Loader node. Add a LTXV empty latent audio node, and connect the audio VAE to the node. To work together, both audio and video latents have to be the same length. To make sure we use the same value, we connect an integer primitive node and use a fixed value of 241, defined before for 10 seconds at 24 frames per second. We can change the frame rate to 24, as this is the training value for the LTX-2 model. The video and audio latents are combined using the LTXV concat AV latent. Add it and connect the audio and video latents. Connect the output latent with the input in the KSampler. To test the workflow, we are going to use one of the examples from the LTX prompt guide. Prompting is very important with LTX-2, but let's talk about that later. For the moment, let's copy and paste the monster truck prompt example. If you look at the ComfyUI and LTX workflow examples, these are confusing. The reason is that they use the sampler custom advanced node. This requires a bunch of nodes to define the sampling process. These workflows are highly customized and optimized, but for starters, it is better to start with a simpler KSampler. Fix the seed. Keep the number of steps at 20 and change the CFG to 4. Euler is a good sampler, and SGM uniform as scheduler works well. Keep denoise at 1. With this first sampler, we create a draft or prototype video that has to pass to a second sampler with the distillation LoRa to create the final video. Thus, delete the image decode and save nodes and start with the second stage. Separate the video and audio latents using the LTX-V separate AV latent node. Connect the video latent output to the LTX-V latent upsampler. In this node, we upscale the LTX video latent by 2. The node requires of the video VE from the checkpoint, so we connect it. Connect now the load latent upscale model node and select the LTX-2 spatial upscaler. Copy and paste with Ctrl-V the existing KSampler. We have to combine again the upscaled video latent with the audio latent, so copy or add the LTX-V concat AV samplers node. Then connect the corresponding audio and video samplers. The resulting latent, connect it to the KSampler. Add a LoRa loader-only node. Select the LTX-2 distillation LoRa model and reduce the strength to a range of 0.6 to 0.8. Reconnect now the model connection, so the model that is run in the second stage KSampler uses the distillation LoRa. We make sure the seed is fixed, and use any seed you like. Reduce the number of steps to 3 and CFG to 1. Use gradient estimation as sampler, and linear quadratic as scheduler. Reduce the denoise to 0.4. Add now a LTX-V separate AV latent node, as we need to decode video and audio separately. For the video, use a VAE tile decoder node. Tiling is needed to avoid running out of memory for long videos. You will have to connect the video VAE from the checkpoint loader. The audio latent is connected to the LTX-V audio VAE decode node. Don't forget this decoder needs to be connected from the audio VAE loader. Combine now the video frames and the audio in a video. You can use the Create Video node. Set the FPS to 24. And add a Save Video node to keep your results. I prefer to use the Video Combine node from the Video Helper suite, but you can use the nodes you prefer. In any case, just make sure that the frame rate is set at 24 and the file is saved as MP4. In the VE decode, set also the temporal size to 4096 to make sure all frames are correctly processed. When ready, run the workflow. This basic workflow is enough to run LTX-2, but you can then start fine-tuning it. For example, you can make it more similar to the ones from Comfy and LTX by using the same negative prompt. The original templates use the LTX-V scheduler, but it cannot be used with the KSampler. Instead, you can use model sampling LTX-V. This node recalculates the sigmas very similarly than the LTX-V scheduler. Just connect the model and the video latent, and reroute to the KSampler. The calculations are not exactly the same, so for this resolution use 1.79 as max shift and 0.65 as base shift. At the end, the resultant text-to-video is rather random, so it is great to experiment with different samplers and schedulers. LTX-2 comes with different camera movement loras. We will try in this example the dolly and LoRa. Try them out and play with them to obtain exciting visuals. Add a LoRa loader model only, select it, and reconnect to the distilled LoRa loader and the model sampling LTX-V node. Of course, what you can also do is to visualize your first stage prototype. As simple as use the decoding part of your workflow and connecting it to the first sampler. We will change now the prompt and use another one. This contains more varied actions in the scene. It also contains an off voice, to see how it works with dialogue. Prompting is very important with LTX-2. They provide a prompting guide in their website. Read and follow their recommendations. Nonetheless, good prompting requires a lot of practice, and trial and error. Moreover, the seed has also a great effect on the results in text and image to video. Alternatively, you can use LLMs like ChatGPT or Gemini to create prompts. For that, take advantage of the user instructions of the prompt enhancer in the LTX template. We are now going to run some prototypes to see if the generations are good. We set, for example, the seed of the first sample to 0. Then set control after generate to increment. Deactivate the second stage sampler, so only the first one runs. Set the queue batch number to the total of prototypes you want to create. In our case 4. Click on Run, and we will create 4 videos. After running, you can see the results of each run clicking on Assets on the left. Inspect the results to choose which one is the best prototype. Take into account these are low-resolution drafts, and only define the main composition. The detail refinement is done in the second stage, so the final result will look different, for both video and audio. When you know which prototype to use, go to the KSampler and fix the seed. Choose the one of the draft video you like. In this case is seed 3. Activate the second stage sampler and video decoding nodes. Ready. Let's run one batch of the workflow.
Atmospheric stabilizers are now active. Please remain within the shield sectors for your safety.
And that's it for text to video. Let's look now how to adjust the workflow to do image to video. Add a load image node next to the empty latent nodes. Choose the image you want to be the reference for the video. In our case, it is already selected. Add the resize images by longer edge node. Set the longer edge field to 1536 and connect the image. Add a LTX-V image to video latent in place node. We connect the image, the video latent, and the video VAE to the node. The output latent replaces the existing input in the video latent in the LTX-V concatenate node. We also need the image to video in place for the second stage. We copy the node and paste it next to the second stage sampler. Connect the output latent from the upscale node to the input of the video in place sampler, and the output to the input video latent of the concatenate node before the second sampler. We are going to slightly change the prompt, so now the lady is talking. Repeat the process to create several prototypes. When you find one which you like, then you can upscale it. And this is the final result.
Atmospheric stabilizers are now active. Please remain within the shielded sectors for your safety.
It has been a lot of fun. LTX2 offers great flexibility. In next videos, we will explore control nets and editing methods. I hope you have learned a bit. Bye!